So finally, we talk about something which is called clearing the objects. And what this is kind of referring to is, like in cricket, when you have to hit the ball or throw the ball for it to hit the wicket, and you want to work out exactly when it hits the top of the wicket. So that, you can imagine, is the wicket, and that's a ball you're throwing, so it just hits the top. So that's what it means. It's just clearing this object there. You can also kind of think about it if you are trying to throw a ball over a fence. So that's your fence, and you want to work out exactly how much you want to throw it until you just clear that fence. Or if you're kicking a ball over a tree. So all it means is that there is something of a certain height here that you need to clear with your projectile motion. So let's look at a question to do with that. So this is what I was talking about with the soccer and clearing the tree. So let's just say a soccer ball was kicked with a velocity of 40 meters per second at the angle 60 degrees to the horizontal, assuming the gravity is 10 meters per second. We want to work out how it just clears a tree 20 meters away, what the height of that tree is. Yeah, so it just clears it, and we know the tree is 20 meters away. Firstly, we want to work out what the horizontal displacement is. And that's because you can see that 20 represents a horizontal displacement to a certain degree. That's a horizontal displacement until there. So using this VT cos theta equation, x equals to 40 cos 60 degrees. And cos 60 is just half. So we work out that x equals to 20t. So that's what our horizontal displacement equals to. But it also equals to 20 as well, because that's what that is there. So what we want to work out, what is the time, why we do this, so we want to work out what is the time here for the ball to get to that tree, essentially, by using those values. So that means dividing both sides by 20, that the time is 1 second. So it actually takes a ball 1 second before it gets to the tree. So what we did here, found out the horizontal displacement, and we know that the horizontal displacement until the tree is 20. So substituting that in, we can find out the time it gets to the tree. And now we've worked out the time it gets to the tree. Can you see how we can use that time to work out the height now? So the vertical displacement. So first thing, let's work out the vertical displacement with t. 10 on 2 gives you negative 5t squared. 40t sine 60 degrees. Sine 60 degrees is just going to be square root 3 on 2. So that's why it cancels the 40 to get 20 square root 3. Because we worked out that the time is equals to 1 when he reaches here, that means that if I substitute t equals to 1 into this vertical displacement equation, I'm going to get the height of the tree. So because I want to find out what the vertical displacement is at that time. Does that make sense? So substituting that in, we have negative 5 times 1 squared, 20 square root 3 times 1, just calculator work. And the height is approximately 29.64 meters. So that height there is about 29.64 meters. So in this question, when you get this kind of question, you have to kind of predict what you need to do. So because we want to find out the height, that means vertical displacement. But we don't know what the time is. But we know the horizontal displacement until that tree. So by working out the equation, we can work out the time, which we substitute into the vertical displacement to finally work out the height of the tree. Excellent. So this is more of a problem-solving question. Let's have a look at question 5 here. So here we want to find the equation of the path. Let's just say that this is someone who's throwing a ball over a 2-meter fence, and this person is 30 meters away from the fence, like that. And they're throwing the ball at an unknown angle, but at a velocity of 30. And what we want to find out now is the equation of this path there. So the equation of the path is given to us by the trajectory, and the trajectory is given to us by combining these two and eliminating t. So firstly, we want to work out the horizontal displacement equation. So that's 30, substitute that in, t cos theta, because we don't know what the angle is yet. With this one, you get negative 10 on 2, so it's negative 5t squared plus 30t sine theta. So don't know what the angle is there either. Substituting in, so all I'm doing here is dividing this by 30 and cos theta and getting rid of that. So making t the subject into this equation here. So wherever there's t, I'm going to substitute in x on 30 cos theta. So you can see that this is what I've done here, x on 30 cos theta into here, and x squared on 30 squared cos squared theta into that t squared there. Now, some cancelling. 30 and 30 should cancel. Now that sine theta and cos theta should become tan theta, and that cos squared theta as a denominator will become sec squared theta on top. And negative 5 divided by 30 squared just gives us 1 on 180. Sec squared theta plus x multiplied by tan theta. All we've done, eliminated t, and that's given us the equation of the path. The only difference in this one is going to be that we don't quite know where theta is. So you can see we still have theta there. And now we're going to do this. I'm going to make this sec squared theta into 1 plus tan squared theta using our identities. So I've just changed this sec squared theta into 1 plus tan squared theta there. And you'll see why in the next section why we've done that, all right? Okay, in this section, I'm going to, with you, find out the angle of projection. So what is the angle that this person is throwing at to clear the fence of 2 meters? Now, this was the equation that we just worked out before. Remember how we changed that to 1 plus tan squared theta? We know for a fact that when its horizontal displacement is 30, so when x equals to 30, the vertical displacement is 2. Can you see that? So at this point here, the horizontal displacement is 30, but the vertical displacement is 2, which means that we can actually substitute those values into here. So for y, I'm substituting in 2, and for x, I substitute in 30 here and 30 there. You can see why I made it 1 plus tan squared theta is because I can make this quadratic over here. The first thing I've done is just multiplied everything by this 180, and then you expand this and cancel down with that. So in this case, we have 1 plus tan squared theta, and that makes this quadratic here. That's why we did that. Having a look at that, you can probably see we're going to have a hard time factorizing it. We have a 5 and 7. It's not going to work out. So we know we should jump straight into our quadratic formula, which is our minus b, which is 30, plus or minus b squared, 30 squared, minus 4 times a times c on 2a. And this is just some calculator work. And you find out that tan theta equals 0.24 or 5.76. And then using inverse tan of that and calculating inverse tan of 5.76, we work out that theta can actually be 13 degrees and 30 minutes or 80 degrees and 9 minutes. So how can that be? So this angle here, so this is our 30 degrees and 30 minutes. But what can actually also happen, if you can imagine, is if you throw it really, really high, it's going to come back down like that. And that angle there is what your 80, what was it again? 80 degrees and 9 minutes are going to be, right? It can either be that small throw or that really high throw, but both of them just clears that fence. So remember, when you're finding the angle of projection to just clear an object, because you have this quadratic here, and also from that diagram, you can see you're going to get 2 answers for what those 2 angles could both be to just clear the fence.